Hello, welcome to Homework Help 9.8. Remember, we're skipping 9.7, so you're not missing a homework assignment. We're skipping it. Okay, here we go. Boom. So the first part is review of like box and whisker plots. So you're just analyzing them. So I'll do a little bit with you. Here we go. There. Describe the spread of data set shown in each box plot shown below, set shown in each box. Include the median, the range, and the interquartile range, all right? That's your IQR, I think is what we started calling it. Okay, so I'll do number one, you have to do number two. So, number one, the median. Your median is this line within your box, okay? This is your median, so it is at 5.5. So your median is at 5.5. All right, this is your Q1, this is your Q3, which I don't think we have to identify. We do not. Okay, so my median is 5.5. That's this line right here. The range, so the range is from your lowest to your highest. What is the range? So we go from 3 to 9. So our range goes from 3 to 9, which is a range of 6. Okay, so your range is 6. You go from 3 to 9, which is 6. Hold on. I don't know why I don't get this ready beforehand. Okay, good. Always have to make sure I agree with the book. Range is 6, and then your interquartile range, your IQR. So that's just the length of your box. So how long is your box? It goes from, is that at 4.5? I think it's supposed to be 4.5 to 7. So it goes from, is it 4.5? Yes. Okay, so you go from 4.5 to 7. 4.5 to 7. Here, I'll draw a line. From 4.5 to 7. There you are. So from 4.5 to 7, that is 4.5, 5.5, 6.5, 7. So 2.5. So your IQR is 2.5. Equals 2.5. All right, so there you go. You're going to do the same thing for number 2. Moving right along. If the box plots above represent the results of 2 different classes on the same assessment, which class did better? So if these were scores on an assessment, like a quiz, which class did better overall? So which class had the higher scores? That's what it's asking you there. Number 4, the 2 box plots below show the low temperatures for 2 cities in the United States. City D is the box plot on top. Okay, so that's this guy. And then city E is this one. So which city would be considered the coldest? So these are your temperature. Here, I'll write that here. These are your temperatures. Okay, these are your temps. So which one is colder? Which one has colder temps? D or E? D, right? D, which is your top one, goes from 20 degrees to 30 degrees. See, 20 degrees to 30 degrees. And E goes from 28 degrees to 38 degrees. So city D, and then explain it however you want, because it ranges from 20 to 30, while E ranges from 28 to 38, 28 to 38. I would want to live in neither of these places. Okay. Do these cities ever experience the same temperature? How do you know? So, is there any overlap between their temperatures? Do they ever have the same temperature? Yes. Okay, we just said this one has a range from 20 to 30. This one has a range from 28 to 38. So they overlap in that 28 to 30 range. So they overlap in this range, right? Oh, that wasn't quite even. They overlap in this range right here from 28 to 30. All right, that's where they overlap. So, oh, yes, I do want to delete it. So, yes. They overlap. I guess it's like where they share 28 to 30 degrees. All right. Is there a way to know the exact temperature for any given day from the box plots? So like if I was like, what was the temperature in city D on May 25th? Can I figure that out from the box plot? No. No. And then what advantage, if any, so sorry, this is no. Here. What advantage, if any, could a histogram of temperature data have over a box plot? Okay, so instead of showing this in a box plot, what if I created a histogram? Okay, generally histograms are just going to be more specific. Histograms are more. Okay, these show the general temperatures. If I were to graph these on a histogram, I'd be able to see like, okay, this amount of days, for this many days, it was 25 degrees. For this amount of days, it was 28 degrees. For this amount of days, so I'd be able to see specifically the amount of days it was that temperature. We can't tell that from a box plot. So I'd be able to tell you, oh yes, for 5 days it was 22 degrees. For six days it was 28 degrees. I would be able to tell you specifics. I cannot do that from a box and whisker plot. All right. This one, I want you to skip A, which is why I crossed it out. I just want you to look at the data sheet. That are scatter plots that have the regression line and the residuals indicated. So I just want you to do B and C. So you're going to create a residual plot. All right, so I'll get you started on this one. Maybe. There we go. So for your first one, oh my, what's your first point here? 1, 2. So at x equals 2, oh geez, how far away is that? So it goes from 25, 26, 27, 28. Okay, so it goes down 2.5. That no, 3. It goes down 3. 1, 2, 3. Okay, it goes down 3. So 1, and it goes down 3. So that means it has to be a negative 3. 1, 2, 1, 2, 3. So it's like right here. Boom. Let's see if that shows up. Yeah. All right. So 1 and like negative 3. Okay. This point is below the line. That's why it's negative, and it's 3 away. This is at 30. This is at 27. Okay, this is 25, 26, 27. Should I zoom in? I can zoom in. Wow. There's a lot. Okay. Let's do the next one. So the next point is at x is 4. Okay, and how far away is it? It is 2, 3, 4. It is 4 away. So it is 4 away. So 4 and what did I just say? And 4 away. So 4, and it is above the line, so we're positive. So 4 and 4. Did I do this one in the right spot? Was x 1? I think x was 2. X was 2. Uh-oh. Sorry, guys. This needs to be 1 over. Because x, I think, yeah, x is 2, and this was 3 away. So 2, 1, 2, and 3 away. 1, 2, 3. There we go. Okay. So we've done the first two. The next one, x is 5. X is 5, and that is only, oh geez, like, I think it's supposed to be 1 away. It's supposed to be 1 away. Yeah. Don't know why they make these so hard to see, but it's fine. So x is 5, and it is 1 away. So 1. This one, x is 5, 6, 7, x is 7, and this point is, like it's at like 19 probably, so 19. So 2. Yes. So I think it goes from 19 to 17. Yeah, because it's 16. So 19 to 17. I think my car alarm is going. Just pretend it's not mine. Okay. Now I lost my train of thought. Ah! All right. X is 7. Did I say that? X is 7, and it's 2 away. And it's below the line, so we have to go negative. So X is 7 and negative 2. So right there. Hold on. Okay. I think that was my car alarm. Sorry about that. Okay. So then we have, oh, this one's exactly on the line. So x is 9, and it's on the line, so that means your residual is 0. Your residual is 0. So x is 9 and 0. So it's right there. It's not, it's on the line, so it's 0. It's not any distance from the line because it's on the line. And then we're almost done. So that's 11, 12. That's 12. And how far away from it? So that's at, so this is at 6. That's supposed to be at 8. It's not. It's like at 8.5. Are they going to make me do that? They do make you do that. That's 12, and then 10, 11, 12. And so it's like 6. This is, sorry, this is 6. Yes, this is 6. This is 8, and it's like at 8.5. If you round up one way or the other, I'm not going to be mad at you. So 12, and then it's below the line. So it's like 2.5 away. So it's like right there. Okay. And then the last one, x is 16, and it looks like it's just 1 away. Yeah. So 16, and it is above the line, so we go positive, positive 1. Woo. Positive 1. Oh, positive 1. Okay, and there you have your residual plot. Goodness. And then you want to estimate your correlation coefficient. So obviously you're going to have various answers here, and that's fine. However, they should all be negative because you have a negative slope. So it's negative 0. These are all really close to the line. These are all really, the farthest away you have was like 4. So these are all really close to the line. So I'm probably going to say like 0.9. You want to throw in a 2, but somewhere around like probably negative 0.8 or negative 0.9 is what I'll be happy with. Definitely, it definitely has to be negative. So anywhere between like -0.8, -0.9, it's fine. Right, and then you're gonna do the exact same thing for number 6 that we just did. And, oh, here. So the following graphs are residual plots. Analyze the residual plots to determine how well the prediction line describes the data. So these are just residual plots. So we don't see their line of best fit. These are just the residual plots they have created. Okay. Residual plot should never be a straight line. So they did not estimate their line well here. You should never have a straight line when you're doing a residual plot. Okay, so you also have one way up here. Maybe that's an outlier though. That's okay. Should not be in a straight. Something like that. Remember, when you have a residual plot, you want to have your dots like equal distance from the origin, basically, from the line. So this is not right. They should not ever be a straight line. If you look at number 2, or sorry, the next one, number 8, this is more what a residual plot should look like. Okay, you have about the same number of points below the line as above the line. They're kind of a good distance away. So this one was better. This one is whoever drew in this line of best fit did a better job. Okay, so that's it. Since the residuals. I think they equally both. Are they equally? Pretty much 1, 2, 3, 4, 5, 6, 7. Pretty close. So I have like 6 that are above and like 7, or maybe 8 that are below. That's pretty good. That's a pretty good one. All right, and that's your homework. That's it. That's all. Good luck.